everyone, welcome to today's talk. So I want to talk about how to perform data science analysis using Elyra. So my name's Yiwen. Firstly, I want to give you a brief intro to myself. I'm a data scientist and developer advocate at IBM Codate team. Here I have my email, my GitHub link, and also my LinkedIn. Feel free to connect with me on any of those. Okay, so just quickly before we dive in, let me just give you a brief overview of everything that our talk gonna cover today. So firstly, we will go and talk about Elyra. Let's discuss what's a data science pipeline. And then I'm gonna give you a short summary of the many projects we work on here at Codate team. Next, we will go on and dive deeper into one of the two Codate projects we're showcasing for you today, and that is DAX, our data asset exchange. And we will use one of the datasets of DAX in this demo. Then I will introduce you to second project, Elyra, which is a suite of AI-centric extensions for Jupyter Lab. And finally, I will give you a demo showcasing how you can combine both of these projects, DAX and Elyra, to produce an effective and efficient AI workflow. And at the end of the talk, we will also leave you with a few resources for you to get started and up running with DAX and Elyra. Okay, so let me firstly introduce you. What is a data science process? So basically, a data science pipeline includes 5 steps from data extraction to result interpretation. Let's start with the simplest example, which is Python script. So what you do is you actually read in some data, do something with the data, and then you push the stuff you want to keep to a file system or save it and output the files. And then you run this on a scheduler or somewhere else. So Elyra coming here, Elyra makes it possible to run Python notebooks instead. I mean, why would you run Python scripts when the Jupyter notebooks are so much easier, right? Usually the notebooks make things a lot easier to understand. It is more intuitive to have, okay, my cat is here. So usually notebooks make things a lot easier to understand. It's more intuitive to have each component to run together continuously and iteratively. So it also makes it easier to tell the story behind the pipeline, and it might grow bigger as a project. So you can think of it as a novel. So each notebook is a chapter. Basically, it's easier to maintain in the long run as well. It also brings in a benefit that if your notebook doesn't have dependencies on the prior notebook, it means you can run the two notebooks in parallel order. Or if they have dependencies to each other, you can run them in sequential orders. So some notebooks might have different requirements than the others, like libraries, frameworks, file dependencies, environmental configurations. We want to make sure the pipelines eventually is portable and shareable. So these factors need to be taken account, and we need to configure these for each notebook separately. We can run Elyra in containers, such as Kubernetes. This will save time and save memory and GPUs because you can run things parallel. Workers can have different hardware configurations to accommodate various workloads. Clusters can scale up and down, depends on your resource need. Also, if you change anything in one notebook, you don't have to rerun the other notebooks one by one, because Elyra will save the efforts by constructing them as a pipeline, so you will run them all with one click. So let's talk about Codate, what we do in Codate team. So Codate is Center for Open Source Data and AI Technologies. We provide AI solutions, which makes things a lot easier for people to create, to deploy, and manage in enterprise. And also we are open source projects. We bring a lot of offerings from IBM Research as well. So if you're interested, feel free to check us out. And also we are open to any contributions from the community. So on the graph on the right side, today I will talk about DAX, which is Data Asset Exchange, DAX, and Jupyter Elyra. Yep. So you might wonder, what is DAX? Because I kind of mentioned DAX twice, right? Data Asset Exchange. So it's basically we have a bunch of data sets on our app website. So part of the data set is from IBM Research, and we have open data license for the data sets and also for business applications and advancing core science. And also for each of the data set, we package with tutorials that shows how to read and analyze the data, as well as train machine and deep learning models on IBM Cloud using IBM Cloud AI services, as well as like multi-cloud AI open source tools. So at the bottom, I put the IBM DAX exchange page. So you can, it will take you to the DAX page. So check it out if you want to. And also in the bottom of every slide, I put the bit.ly link. So that is the slide I'm talking about today. So if you want to see the slide again, if you miss anything, you can always come back. Okay, so this is just a brief review of a brief preview of what we have. So we have data glossary and data preview for each of the data set. And also we have access to the notebooks that are hosted in Watson Studio. So if you're interested in a notebook, you can just deploy, run on Watson Studio directly. And also you have access of the data from Cloud Pak for Data. And also we have industrial accelerator to the data sets. Okay, so now let's dive into Elyra. So at its core, Elyra is a set of extensions for Jupyter Lab, catered into people who like to work with artificial intelligence and machine learning using notebooks. So Elyra's goal is to help data scientists, machine learning engineers, and software developers through the most common model development lifecycle complexities. So if you would like to access the GitHub repo or the docs, you can follow the links we have shared here on the screen, which is GitHub Elyra AI/Elyra. So Elyra was officially announced as an open source project by IBM this past April. Elyra boasts a host of features to achieve its goals, which we will discuss shortly. For now, notice from the preview of Elyra's UI on the right here that Elyra doesn't radically reinvent Jupyter Lab to provide you with all of its enhancement functionalities. It simply extends the distinct Jupyter Lab environment that we have all come to know, love for years, with added tabs, toolbars, and launchers. So what can Elyra actually do for you? Well, we can really break down Elyra's core features into 5 items. First, Elyra provides an easy-to-use notebook pipeline widget editor. So why build your next AI model using a pipeline editor? Well, it's because Elyra provides a simple visual way to convert multiple notebooks, covering processing steps, experiments, optimization, and deployment, all into batch jobs or workflows. Second, Elyra supports running notebooks as batch jobs directly in the UI, making model training easier. Third, Elyra supports easy creation and insertion of reusable code snips. This allows users to manipulate reusable piece of code, making programming in Jupyter Lab more efficient by reducing repetitive work. Fourth, Elyra pipeline support Git version control, allowing rolling back to work versions of the code, backup, and most importantly, sharing amongst team members. Fifth and finally, Elyra exposed Python scripts as first-class citizens. This allows users to locally edit their scripts and execute them against local or cloud-based resources seamlessly. So before we up and run, there are several prereqs to Elyra. We need Node.js 12 plus, Python version 3 and above, and also you better have Jupyter Lab version 2 and above installed if you would like to try the most updated version of Elyra. So to install Elyra, I copy paste a few easy links here. If you want to use it, you can try this on your local computer. Okay, so everything is ready to go. Let's start a live demo. Now, let me walk you through a demo by running 4 notebooks using Elyra. I will introduce you 2 ways to run your pipeline,
both on local machine and on Kubeflow pipelines. To build a pipeline, you can simply drag and drop the notebooks onto the canvas and then connect them, just as easy as drawing a graph. You can arrange the notebooks in sequential or parallel order. You need to configure notebook properties for several informations. We put the environment variable dataset URL as a dataset download link from DAX. We copy-paste the link into a section. This notebook produces output files, so I specify the file name as gfkweather.csv, which is downloaded through the first notebook into the directory. The output files are uploaded to the cloud storage or saved in local directory after a notebook processing complete. We also need to select a Docker image that will be used to run the notebook. You can bring your own image or choose from the predefined public images. We choose pandas as a Docker image here because we mainly use pandas and NumPy packages in the notebooks. We could only select one Docker image each time. However, if you're running on your local machine, the image you choose does not matter. Also, you can declare the file dependencies as gfkweatherclient.csv, but this is not necessary since files are already in the same folder. I redefine the name of the pipeline by right-clicking my trackpad, changing the name to event.pipeline. Also, you can add comments to provide short descriptions. This helps your colleagues know the function of each node before going into it. Now, everything is all set. Let's save the pipeline and submit it to run locally. The running logs are shown in terminal. If everything completes successfully, a message will pop up. The run outputs will be shown in the notebook cells. See on the left side, the notebooks are just updated a few seconds ago. Now, let me quickly walk through the content of each notebook. Firstly, the load data notebook downloads, extract the zip file through the dataset URL link, and save it as a gfkweather.csv file. The Part 1 notebook loads the dataset downloaded from the previous notebook, replace the wrong values such as none, t, 0.02, 0.01 second, filter out everything out of the range, converts columns to numerical types, clears out missing values, renames the columns, and then save the clean dataset as gfkweatherclient.csv file. The Part 2 notebooks select the 5 columns from the clean data and visualize the trend. Also, it explores the dependencies between the 5 columns. Then it visualizes the trend of the rolling average in 2017. In the Part 3 notebooks, this explores the approaches to predict future temperatures by using the time series dataset. It creates training, validation, and test split, and then it trains the dataset and then compares the performance between different baseline models using the mean squared error. And it built a RIMA model predictions for the first 48 hours of the validation set. You can get the notebook on DAX page. By clicking on Preview Notebooks, you can see we have 3 notebooks very similar to what we have in Demo Pipeline. The notebooks were designed to run on Watson Studio and IBM Cloud. I made minor changes to the notebooks to fit this into the Jupyter environment. Now, let's submit and run this pipeline on Kubeflow. Before running, you need to configure a runtime by putting your credentials into each section. I already pre-configured my runtime, so now let's submit the pipeline on Kubeflow. In the run process, Elyra generates, gathers, and packages the required artifacts, upload them to cloud storage, and triggers pipeline execution in the selected Kubeflow pipeline environment. The pipeline runs are listed in the Experiments panel. The Graph panel displays the execution status of each node. You can see the Part 1 notebook is completed and has green checkmark at the right top. After the run is complete, you can access the pipeline's output artifacts using any supported S3 client. In here, we have all input and output files listed. Clicking on the data folder, which includes the GFK data file and the clean version. All tarballs are input files. By clicking on one of the output files and download, you can see the result of the notebook is saved in the output cells.
So that's everything I want to talk to you today about the demo. If you want to get involved, if you're interested in Elyra and what we talk about today, you can get started using the Elyra readthedocs.io. And also you can check our GitHub link. And also if you want to open any bug reports, enhancement requests, or code reviews, please go ahead to our Elyra GitHub. And also, I put the DAX link here to our data access exchange where we have the data sets and also the tutorial notebooks. And more than that, we also has a DAX notebook GitHub. That's a notebook we use today in our demo. So please check it out as well. Okay, so here are several related links that I talk about today. Please feel free to check them out. So thank you so much. That's everything I want to share with you today. Bye.